Have you ever wondered what goes into making a roll of film? Since 1879, ILFORD products have provided photographers with a way to see the world in black and white. To take a look behind the film, we must travel to where it's made, a little village called Mobberley. In Cheshire, England, just 15 miles south of Manchester, lies the quiet village of Mobberley, home to 140 years of ILFORD filmmaking magic through the Harman Technology factory. The site, first acquired by ILFORD in 1928, manufactures black and white films, paper, and chemicals for photographic use. Harman Technology's dedication to quality starts with its employees. If you were to ask anyone how long they've worked for the company, decades of experience tally up.
I've been in this role now for just over 20 years.
Worked for ILFORD for 15 years.
34 years.
35 years.
Going on 32 years.
Could have been doing it for that long now, it's just like second nature really, but I really enjoy what I do.
Both Kevin and I have been here for over 30 years each. I've been the plant manager of the emulsion making plant for 20 years. And in the plant we make photographic emulsion.
We begin at the start of the process with photographic emulsion, the key ingredient in the making of photographic film and paper.
So we'll go inside and have a look at what photographic emulsion looks like. Yeah? Yeah. So this is photographic emulsion, which are very small crystals of silver halide dispersed in gelatin. So over here is an electron mic of what the crystals look like, and they're dispersed in gelatin. After the product is made, it's put into a cold store and then it's spread onto film and paper base for photographic customers.
The emulsion is created in total darkness, and with the help of this machine, is pumped into 5-kilo bags and placed into a cold storage set at 6 degrees Celsius.
Nice and cool.
There are different recipes for photographic emulsion, with an important variable being the crystals. The crystals help determine important factors for a photographer, such as the grain of the film, as well as its ability to capture light, its ISO speed.
In general terms, the greater the surface area of the crystal, the faster it will be. As you go through from Pan F to FP4 to HP5, you're increasing speed, the crystals are bigger, and in general terms, the iodide content is greater as well.
Before any of the emulsions can go into full-scale coating production, they're heavily tested by research and development scientists on a smaller scale.
I'm Beth and I'm one of the scientists here at Harman Technology. Me personally, I get to work in both analytical and product and development, so I get to start right at the beginning from raw material testing and get to have a product come in, see exactly what it is and if it's the right product, and then I get to come downstairs and put it in my own coating package. And it's part of my job in research and development to make sure that you're giving the customers confidence in when they put that film into their camera, that they're going to get a picture out that they expect to get and not something that's completely different, and so that's why we test our products so much. So once we've formulated a coating package, we'll bring it down here to our pilot coating facility, and here is a much smaller version of our main production facility. It's about a 20th of the size. We'll bring it here and we'll put each layer into one of these. So we'll put non-stress, wetting agent, emulsion layer, and then we'll connect the pumps, and it's all done by computers, our pump rate, so we can decide at what rate that they come through the 3-slot coating head over here. And once they're coming through smoothly, Sylvia can decide when to push the coating head towards the film and start coating the package.
Check line 3.
And we can also change the coating speed to decide how much is laid down, which can give us our characteristics of how much silver's on there. And once that's done, it will go through the dryer, which is in a room behind us. And once they've been incubated, we will test them for a range of things such as granularity, hardness, how much silver's on there, is it what we expected? And from there we can decide whether to recoat on our pilot machine or take it through to production and scale up the whole process.
This is the coating plant, where bags of gelatin emulsion from the emulsion plant are melted at 40 degrees Celsius in a vessel and mixed with the chemical ingredients to form what is called the coating circuit. Giant rolls of paper or film are fed through and can be coated with emulsion at speeds of 30 to 100 meters per minute.
So this is number 14 coating machine. There was actually only 12 beforehand. No one wanted to call this one number 13. Superstition. Now we use cascade coating technology, so the solutions will flow through the chamber, out of the exit slot, down the slide, and then the base will come and take those solutions that are 40 degrees away from the coater. The second layer flows right over the top and the third layer over the top.
To see the next part of the process, special jumpsuits, foot covers, and hairnets are required to keep the area as clean as possible. We're entering the setting room, where freshly coated base is cooled on rollers.
We chill by contact with cold rollers, so we apply a vacuum to get maximum contact, and then we go into our dryer,
where in 19 sections, the web of paper or film is dried slowly over time to avoid imperfections.
At the end of the conditioner we have a scanner which is scanning the web thousands of times per second. It's looking for changes in signal. It can be used in transmission or reflection depending on what product we're on. So it's looking for a change of signal. So if it sees a bubble, it'll see a change of signal. That then gets passed to our QC area, and they have a pattern that is printed out both of the length and across the web.
After the coating process is complete, there's just one problem. How do you move giant, light-sensitive rolls to the next stage of the process, located in an entirely different building? The solution lies in coffins.
They're effectively film roll boxes, but we call them coffins because they look like coffins. They're just effectively metal boxes which the film sits and rests in. It's a light tight clearly, and they're used to transport the film from the coating area to the finishing area.
Before the sensitized base can be turned into the 35mm film we all know and love, the metal cassettes must first be created. That's where the CMU, or cassette manufacturing unit, comes into play. Here's Anthony to tell us more about the process.
The CMU line manufactures the cassettes for film to be put into. It starts off with a sheet that's fed into the machine where it's stamped with the mouthpiece. Then this is flipped over, goes through an oven. A strip of velvet is applied at either side of the mouthpiece. This is then flipped back over by the machine and goes into the velvet cutter. A guillotine cuts it into a single unit. This is then pushed in to the forming head and it's squished into the size of a cassette. This then travels down the line where a spool is pushed in and an end cap is put on either side, and these are then crimped.
After the 35mm cassettes are formed, they're moved down the line to marry up with the film. These machines work hard to perform many small tasks to go from this to this.
Okay, so we're on the 35mm cassette making line, and the first thing that happens is we receive a parent roll from M14 and it's slit into 31 pancakes. So it's just 35 millimeters in width and it's around about 600 meters in length. These pancakes are delivered to the line in light tight boxes. This is a training aid, so don't worry.
This pancake is loaded onto a rotary perforating head, which creates what we know as the sprocket holes. The information of the film, such as the film stock, frame numbers, and unique 4-digit batch number are also signed onto the film. Meanwhile, a hopper orients the cassettes into the proper direction for the barcode to be read, ensuring the right film stock is entering the cassette. A conveyor then takes the cassettes into the darkroom where the machine spools off either 24 or 36 exposure rolls. The loaded cassettes then exit the darkroom and head over to packaging. The 120 process is a different story entirely. Instead of being contained within a cassette, 120 film is wrapped onto a plastic core with paper backing, and then wrapped into a foil wrapper and boxed.
Film is sent down from our slitting machines upstairs in light tight boxes. We transfer those slits over to light tight magazines, and the magazines are loaded onto our roll film machine,
which places the film on a core, adds a paper backing, inserts exposed and unexposed labels, and deposits the final product into a bin. As the bins fill with film, a technician moves them across the room to the foil wrapper machine, where film is transferred to be wrapped in shiny silver. The rolls travel up this conveyor where they're sent through the foiling machine. The foil is stamped with the film stock type and sealed around each roll. A bin full of foil wrapped rolls is then collected and sent to the boxing machine. So how do Harman Technology ensure that each roll of film you load into your camera is reliable? That's where the quality control specialists come in, who work concurrently with film production to ensure the line is producing the best possible product.
Hi, I'm Kevin Clark. I do quality control for Harman Technology, ILFORD Photo. This is my kingdom, should we say. This is what I enjoy doing the best. My job is to make sure that any work we produce is top quality and no faults go out to the customers. I'll be looking for scratches, repeat marks, anything really. We'll just get anything that 14 find, bring it down, process it, and then look for the faults. So say they usually get 4 tests in about every 4 to 5 minutes. Roll film would be about every 15, 20 minutes. And we have to keep up with it to make sure we don't produce any rubbish.
At the end of the 35mm and 120 lines, plastic sealed bricks of film are boxed and loaded onto pallets by the machine. From there, they're sent to the warehouse where they await their final destinations.
My name is Duncan Appleton. I've been with ILFORD since 1986. I am the warehouse manager. The warehouse receives and stores goods manufactured on site. We then receive orders for customers and we ship them on a daily and weekly basis. So, for instance, we've received this pallet here from our film finishing department. We will store this pallet on stock until such time we receive a customer order, where we will split it down to satisfy that order, and we can then ship it both within the UK, within the European Union, to the USA, Australia. We're effectively shipping globally.
The next time you venture into your local camera shop to buy a roll of ILFORD film, you'll likely already be contemplating the images you'll make. But perhaps now you'll also think of the hard work that goes on behind the film and the dedicated staff at the factory in Mobberley.